Hi, I'm Atal Feroz, student of Einstein Academy of Excellence. I study in Foster High International School. Einstein Academy, started by Mr. Ramesh, is very famous in and around Sainik Puri. And if you want to be the top, Einstein Academy is the best place for you to learn.
Fine. So to discuss Carnot cycle. So Carnot cycle will be teaching at the end of thermodynamics, in which what we require to learn this Carnot cycle. First thing is work done in isothermal process. That we require number one. Number two is work done in adiabatic process. Second one. Third one, what is Cp? What is Cv? Cp minus Cv is equal to R. First law of thermodynamics. Next, work done by the gas or on the gas, which is P into dV. Then heat engine. So if we have this particular knowledge, then only we can study Carnot cycle. So ये पढ़ने के लिए क्या चाहिए? These all things we require it as. So work done in isothermal, work done in adiabatic, Cp-Cv relation, first law of thermodynamics, dW is equals to P into dV and heat engine. We'll discuss one by one, then we'll go for Carnot cycle. So what we require is first work done in isothermal process. So keep ready, work done in isothermal process. Work done in isothermal process. Work done in isothermal process. First, what we require to know is what is isothermal process. Iso means constant or as single down. Isothermal means temperature is constant. Temperature is constant. Any process which temperature is constant is called the isothermal process. Correct? Any process. The process in which temperature is constant. Temperature is constant. Then that is called isothermal process will be called. Now when temperature is constant, according to ideal gas equation, if I take ideal gas equation, PV is equals to nRT. PV equal to nRT. For a given gas or given system, when we take number of moles is constant, R is constant, and if it is an isothermal process, temperature is constant. All three parameters are constant. Then PV equal to constant. PV equals to constant. That means in isothermal process, PV equal to constant holds good. PV equal to constant. PV equals to constant holds good. That pressure and the volume equal to constant. Now, in this one, what we require to calculate is work done in isothermal process. Let us take one system. If I take this is a system, this is a cylinder. there एक piston लगा हो, एक piston है, इसमें gas is there. This is the gas. अब देखो when piston is pushed down, you are applying force or pressure on this particular gas. That means work is done on the gas. उसके बाद में piston को छोड़ दो, और piston को छोड़े तो क्या होता? वो ऊपर उठ जाता. That means work is done by the gas. Now let us take this is V1. Either it is moved to a distance. This distance it is moved off for dx. Then now volume क्या होगा? बढ़ जाएगा V2. So V1 and what? V2. Initial volume is V1. Final volume is V2. So work is done by the gas. Work is done by the gas. So कौन कर रहा? कौन पुश कर रहा है इसको पिस्टन को? This gas is pushing in the backward direction. So V1 and V2. Now let us take a small work done. ये distance के लिए small work done dW समझो. A dW equals to P into dV because pressure is what? Constant. Pressure constant into volume dV. Change in volume is dV. This is nothing but relation between work done and pressure and volume. The pressure को constant रखा. So when pressure is also changing, volume is changing, both are not possible. So एक तो constant रहना पड़ेगा. So pressure is constant, volume is changing. अब ये isothermal process में क्या है? PV is equal to constant है. अब मैं क्या लिख सकता हूँ इधर? PV equals to nRT. सही बात है ना? अब P तो constant है. So P को मैं क्या लिख सकता हूँ? V by nRT. सही बात है ना? V by nRT. लेके इधर substitute कर. If you substitute it as, then otherwise dW, this is to be integrated. मेरे को एक छोटा वर्क डन है, small work done. मेरे क्या होना? Total work done चाहिए. So total work done के लिए 0 to W. इधर V1 to V2. pressure V1 to V2. अब pressure को बाहर निकालो as it is constant. Constant है ना भैया? So constant है देखो. So dW integration of dW is what? W equal to. So P को बाहर निकालो. So P is nothing but integration of V1 to V2 into dV. Into a dV. Right? There एक छोटा change. तो देखो Vp क्या होता है इधर? P को निकालना पड़ेगा nRT by V बन जाएगा देखो. So just cross multiply. कोई identify नहीं कर. So P को इसे क्रॉस कर. Now P को देखे इधर सब्स्टिट्यूट करो. P को सब्स्टिट्यूट करेंगे. अगर सब्स्टिट्यूट करें तो क्या होता है तुम्हारे को? W equal to P nRT by V integration of V1 to V2 into dV. अब देखो इधर n तो कांस्टेंट है, R कांस्टेंट है, टेम्परेचर कांस्टेंट है. टेम्परेचर का को कांस्टेंट? इट इज एन आइसोथर्मल प्रोसेस. अब V तो वेरिएबल है, V तो चेंज हो रहा, V1 to V2 को चेंज हो रहा. तो V को अंदर लेके जाओ. Then we can write it as W equals to nRT integration of dV by V, which is nothing but V1 to V2. V1 to V2. अब क्या चाहिए तुम्हारे को? Integration of dx by x, which is nothing but log x. Integration of dx by dx is what? Log x. अब देखो इधर लेते हैं तुम्हारे. उधर से W equals to nRT log V applying limits V1 to V2. This is basic. अब पहले तो इधर तो कॉपी करो, उसके बाद में मैं क्या करता हूँ? erase करने के बाद फिर स्टार्ट करेंगे. फर्स्ट कॉपी करो, इधर रब कर देना. I drop this one. Copy first. W equals to nRT, ये तो कांस्टेंट है, into log of base E V applying limits V1 to V2. उसके बाद क्या करना? applying limits upper limit minus lower limit को करना. So W equal to nRT log. So log of base E V2 minus V1. Upper limit minus lower limits. Upper limit minus lower limit. देखो इधर base E है. Base E को निकाल देना. We have to remove that base E. कैसे निकालना? देखो ये base E निकालने के लिए हम क्या कर सकते हैं इधर? We can make it as that one. W equals to nRT. This has to be multiplied with 2.303 log of base 10. Log of base 10 minus V1. एक इसके लिए बोले तो दिस इज वैलिड फॉर कैलकुलेशन. अगर तुम्हारे को n वैल्यू दिया, r वैल्यू दिया, t वैल्यू दिया, v1 v2 दिया, ये इसमें सब्स्टिट्यूट नहीं कर सकते. दिस फॉर्मूला इज नॉट वैलिड फॉर कैलकुलेशन. सो कैलकुलेशन को वैलिड क्या है, ये इक्वेशन है. उसको क्या करते हैं, e को निकालते हैं, ओके, एक्सपोनेंशियल. दिस हैज टू बी मल्टीप्लाइड विद दिस टर्म. नाउ दिस इज वैलिड. दिस work done is valid to calculate the work done in isothermal process. So here what is work done in isothermal process? This is the standard equation, nRT into 2.303 log base 10 V2 minus V1, right? So here let us take हम क्या करें, पहले प्रेशर को कांस्टेंट लगाए. प्रेशर को क्या करें, कांस्टेंट लगाए. अब क्या कर सकते हैं, अगर वॉल्यूम को कांस्टेंट करके प्रेशर को चेंज करा समझो, तब क्या होगा तुम्हारे को, इट विल बी चेंज्ड. दिस इक्वेशन में बी चेंज्ड. नाउ लेट अस टेक PV इक्वल्स टू कांस्टेंट. सही बात है, PV इक्वल टू कांस्टेंट. थर्मोडायनामिक्स PV इक्वल टू कांस्टेंट. सो P इक्वल्स टू K by V और P is proportional to 1 by V. That means I can write P1 by P2 equals to V2 by V1. P1 by P2 is equals to V2 by V1. It's inversely proportional. Inversely proportional बोलते हैं in terms of pressure P1 minus P2 लिख सकते हैं. Then V2 minus V1. Pressure is inversely proportional to volume. So V2 is greater, बोलते हैं P1 should be greater. So this can be written in terms of pressure. W is equals to nRT into 2.303, the thing right here. So in terms of pressure चाहिए, just take W is equals to nRT 2.303 log base 10 P1 minus P2. लिख सकता हूँ ऐसा? कैसे लिख सकता हूँ मैं? क्या बोलता हूँ? Pressure is inversely proportional to volume. तो volume is greater, pressure is what? Less. अब V2 बड़ा है बोले तो P2 is less. So V1 छोटा है बोले तो P2 is less. So V1 and what? P1. A less, this P1 is more. So these are the two equations we should know in work done in isothermal process. Is it clear this one? So isothermal process क्या है? Temperature remains constant. एक ही definition में हो जाता है. Process in which temperature remains constant is called isothermal process. उसके बाद में work done in isothermal process we are calculating. So work done is, this is the two ways we can express work done. Is it clear? Just note it down and we'll continue. Now the continuation of this one or this work done can also be expressed in a standard form. Auto expressed in standard form. W is equals to nRT into 2.303 log base 10 V2 minus log base 10 V1. So we know that log of m minus log n क्या लिख सकते हो भैया? log m by n लिख सकते हैं, राइट? अगर इधर बेस 10 लगो, इधर बेस 10 लगो, इधर बेस 10 आ जाएगा. So this can be in a simplified form that we can calculate. W is equals to nRT into 2.303 log of base 10 V2 by V1. V2 by V1. Similar manner, we can write W is equals to nRT into 2.303 log base 10 P1 by P2. So these are the two standard forms of work done in isothermal process. Right? So to study Carnot cycle, we require work done in isothermal process. So here work done, these two equations are required for us to do दिस कार्नोट साइकिल। उसके बाद में क्या चाहिए हमारे को, वर्क डन इन एडियाबैटिक प्रोसेस चाहिए। सो टू कैलकुलेट वर्क डन इन एडियाबैटिक प्रोसेस, व्हाट वी रिक्वायर इज what is first law of thermodynamics, then after that what is a Cp, what is a Cv, okay, specific heat of gas at constant volume, specific heat of gas constant pressure, उसके बाद में what is the relation between Cp and Cv, उसके बाद में what is the relation between pressure and volume in adiabatic process, उसके बाद में we will be discussing work done in adiabatic process, उसके बाद heat engine, then we can start Carnot cycle. Now first law of thermodynamics, next we keep heading first law of thermodynamics. First law of thermodynamics, this results directly will be using in Carnot's cycle. This is very important question even in IIT, JEE or NEET, or we can say in your board exams. Why? Because these many concepts, almost all thermodynamics total is included in this Carnot cycle. इसलिए वो एक Carnot cycle को पूछे तो बस हो गया, वो पूरा thermodynamics chapter ही आ गया उसमें. So everything is there involved in Carnot cycle. Now let us see first law of thermodynamics. First law of thermodynamics. Thermodynamics. First law of thermodynamics. Now what is first law of thermodynamics? Here if you take this as a system. System means it may be a gas. System means pressure, volume, number of moles, mass, temperature, everything taken to be consideration. When you give heat to the system, dq is the heat given to the system. It is utilized in two ways. To increase the internal energy and to do the external work done. To do what? External work done. Just now we discussed external work done is P into dV. P into dV. So this can be written as P into dV, external work done. Now here it is having pressure, volume, number of moles, okay, and temperature, mass of the gas. Like this, these are the parameters of thermodynamics. Now if you take dq can be written as du plus dw. This is what first law of thermodynamics. So when you take dq is equals to du plus dw. That means whatever the heat supplied to the system is utilized in two ways. To increase the internal energy of the system and to do the external work done. That is nothing but P into dV, pressure into change in volume. Or this is dq equals to du plus P into dV. Right. P into dV. Now what we require in this one? What is a du and what is the heat? If you supply this heat at a constant volume, what happens? If you supply the heat at constant pressure, what happens? If I am supplying constant volume, let us take. If I am supplying at constant volume, then the total heat is utilized only to increase the internal energy. Work done तो zero हो जाएगा, कहीं को zero होता भैया, देखो. So when you apply dq at constant volume, अगर apply करें तो du ऐसे रहेगा, du plus, अब क्या हो जाएगा तुम्हारा को P into dv. dv बोले तो क्या है? Change in volume. P into change in volume को ऐसा लिख सकता हूँ ना, V2 minus V1. ऐसा तो लिख सकता हूँ मैं, V2 minus V1. So initial and final constant volume का मतलब क्या है? V1 equals to V2 equals to V, which is nothing but constant. ये पूरा constant है. अब V1, V2 are what? Equal. Then dq at a constant volume equals to du plus 0. That means dq at a constant volume is equals to du. That means अगर तुम heat, if you are supplying it constant volume to a system, it will utilize only to increase the internal energy. External work done is 0. अगर if you are applying at constant pressure, dq at constant pressure, if you apply at constant pressure, अब क्या हो जाएगा तुम्हारे को? Here dq at constant pressure दोनों तरफ से यूज हो जाएगा. That is du plus p into dv. समझा? So dq at constant pressure du plus p into dv. प्रेशर तो कांस्टेंट है भैया, dv वॉल्यूम तो चेंज हो जाएगा तुम्हारे को. प्रेशर जब कांस्टेंट है, वॉल्यूम इज चेंजिंग. So it is utilized in two ways. It is utilizing in two ways. इधर एक सिंपल लॉजिक है. किस केस में, फर्स्ट केस और सेकेंड केस में कौन सा ज्यादा हीट चाहिए? इधर एट कांस्टेंट प्रेशर, कांस्टेंट प्रेशर में ज्यादा हीट सप्लाई करना पड़ेगा. ठीक बोले तो इसमें दो तरह से यूज हो रहा हमारा, du हो रहा और p into dv. Two ways it is utilizing. It is utilizing. That means dq at a constant pressure is greater than the du at a constant volume. Is it clear this one? So this is the information from first law of thermodynamics we require for Carnot cycle. उसके बाद में what is specific heat of a gas at constant pressure, specific heat of a gas at constant volume. Okay. If you take this heat is supplied to this one at constant volume. If it increases 1 degree rise of temperature for this gas, then I can write it as dq is proportional to number of moles or mass, we can take it as, into dt, change in temperature. dq is proportional to n into dt, number of moles and change in temperature, or dq equals to some constant cv into n into dt. So dq can write as du or cv into n into dt. So this is at a constant volume. So cv equals to dq at a constant volume by n into dt. So this is what specific heat of a gas at constant volume. Specific heat of a gas at constant volume. Similarly, if you take pressure, Cp equals to dq at constant pressure by n into dt. So these two things we require. Okay. Again for Carnot cycle. Till here you copy down, then we'll proceed. Now, this one, Cp, see what we got the result here, dq at constant pressure is greater than dq at constant volume. So now let us see further how we can proceed from this one. So क्या चाहिए था? Cp minus Cv. So what we are going to derive here, Cp minus Cv is equals to R. This is what we want to derive. अब देखो इधर dq when you are supplying it constant volume, it is utilized only to increase the internal energy. That is dq at constant volume equals to du. That's all. अब इधर dq at constant volume क्या है भैया? cv into n into dt. Substitute कर दो. So cv into n into dt equals to du. एक इक्वेशन आ गया. अब क्या चाहिए? dq at a constant pressure equals to du plus p into dv. अब dq at a constant pressure को क्या लिख सकते हैं? cp into n into dt. सही बात है ना? वो dq at constant pressure को क्या लिख सकते हैं? cp into n into dt equal to du क्या लिख सकता हूं मैं? cv into n into dt plus p into dv. So ये result से ले लिया. Okay. So now this is not required on the boards. Let us erase. क्या होगा? Cp into n into dt. We take this to the step. Cp into n into dt minus Cp into n into dt is equals to p into dv. अब n into dt को कॉमन निकालो. So Cp minus Cv into n into dt equals to p into dv. ये तो इक्वेशन नंबर 1 लगा. Right? Cp minus Cv n into dt, p into dv. We'll take a ideal gas equation for this one. For the ideal gas equation, PV is equals to nR into d. Pressure को constant लगाओ. Volume is changing, that is P into dV equals to n into R into dt. सही बात है. n is constant, R is constant, temperature is changing. So change in temperature, because the Cp में change हो रहा, Cv में change हो रहा. That means whenever you are supplying heat at constant pressure, there is a change in temperature. Whenever you are supplying heat to constant volume, there is a change in temperature. उसके हिसाब से मैं क्या लिख रहा हूँ? PV is equals to nRT. That can be written as P into dV is equal to nR. This is equation number 2. दोनों को equate करो. अब Cp minus Cv into okay n dt, n dt कैसे लगाओ? n into dt is equals to n into R into dt. So this two will get cancelled. n into dt will get cancelled. और क्या बच गया इधर देखो? Cp minus Cv equals to R. इसमें क्या प्रूव कर रहे हैं हम लोग? ऑलरेडी वी प्रूव्ड दिस वन. dq at constant pressure is greater than constant volume. कैसे प्रूव कर रहे हैं? at constant volume अगर तो सप्लाई करें तो it is utilized only to increase the internal energy. सही बात है. When you are supplying heat at constant pressure, it is utilizing in how many ways? 2 ways. That is to increase the internal energy and to do the external work done. So if you take theoretically, it is greater. So dq at constant pressure is greater than dq at constant volume. Theoretically. Now, if you are taking mathematically, this is also called Mayer's relation. Cp minus Cv, इधर लिखूं मैं. Cp minus Cv equals to R. बोलो तो इधर Cp is greater than Cv. सही बात है. How much greater? Let us see. So Cp, right? इधर Cv को लेके जो Cv is equals to Cp plus R. That means it is greater by a parameter of how much? R or Cp. Cp equals to, this is a Cv plus R. So Cp is greater by how much factor? R factor. सीखा हम लोग पहला वाला फर्स्ट वन इज isothermal process, work done in isothermal process. PV is equal to constant. मैं बोल रहा हूँ आप मान रहे हो, कैसे मान रहे हैं? तो isothermal process क्या है? टेम्परेचर कांस्टेंट है, PV is equal to nRT, टेम्परेचर कांस्टेंट, चलो भाई PV is equal to constant मान रहा है। मगर मैं एडियोबैटिक प्रोसेस में PV पावर गामा कांस्टेंट बोल के बोलता हूँ, वो कैसे मान सकते? How you can take it to be granted PV power gamma is equal to constant in adiabatic process? ये gamma क्या चीज है? Gamma is nothing but a ratio of specific heats. So that is gamma can be written as Cp by Cv. Cp by Cv. So gamma is nothing but a degree of freedom. So gamma values will be differ for monoatomic, diatomic and triatomic gases or polyatomic gases, right? So this is a ratio of specific heats. Gamma is equals to 1 plus 2 by F. That's a formula for that one. F is nothing but a degree of freedom. So degree of freedom, again that will be a different topic. We can calculate that. Now for time being what we require is gamma is nothing but a ratio of specific heats, or Cp is equals to gamma into C. That means we can also say that Cp is greater by gamma times of Cv. It is greater. ऐसे भी बोल सकते हैं। अब मैं क्या बोल रहा हूँ? एडियोबैटिक प्रोसेस। तो ये पूरा कैसे सीख रहे हम लोग? To calculate work done in adiabatic process. To calculate work done in adiabatic process, our first assumption for me is PV power gamma is equal to constant. PV power gamma equals constant. Kaisa? So how it will be? So first we will do the derivation for that one. PV power gamma is equal to constant. It is a very lengthy derivation, but सीखना पड़ेगा. We should know that one definitely. Then only we will be getting some confidence, or we have a feel of what doing work done in adiabatic process, right? So note it down, then you keep heading work done in adiabatic process. Work done in adiabatic process. Adiabatic process. So what is adiabatic process? Adiabatic process. So directly we can say isothermal process is nothing but temperature remains constant. Temperature remains constant. PV is equals to nRT. nRT, temperature is constant, PV equal to constant लिख रहे हैं। किसमें? isothermal process में। isothermal process। अब देखो adiabatic process में heat remains constant. dq equal to 0. dq equal to 0. All other parameters are changing. Pressure will change, volume will change, temperature will change. So if you take PV is equals to nRT, in this pressure, volume and temperature, all three are changing. Then that process is called adiabatic process. Right? Now, which equation holds good? Either PV is equal to constant, आसानी से लिखती है। कहीं को बोले तो इधर temperature A constant है, मगर इधर dq is equal to 0 है। इसमें प्रेशर, वॉल्यूम, टेम्परेचर ऑल आर चेंजिंग। सो कौन सा इक्वेशन एडियोबैटिक प्रोसेस में आ जाएगा? Then we'll discuss right now. Okay. First, what we'll do is we'll take first law of thermodynamics. First law of thermodynamics: dq is equals to du plus dw. Right? dq is equals to du plus dw. Now dq is equals to, which is nothing but 0. So du plus dw equal to 0. एक तो आया। Now, what is next du? A du क्या है? So du is nothing but just now we discussed n into Cv into dt. लिख सकता हूँ ना? n into Cv into dt plus dw क्या लिख सकता हूँ? p into dv equal to 0. देखो क्या क्या चीज इधर we are using it. So du is nothing but du n into Cv into dt. Next we are using dw is equals to p into d. दोनों यूज करेंगे इधर. अब p into dv cv को क्या लिख सकता हूँ? cp minus cv equals to r. और cp को क्या लिख सकता हूँ? मतलब इधर लेके आ जाते तो cp minus r is equals to cv. सही बात है. cv को cp में देखो a b यूज करूँ मैं 1 2 3 इक्वेशंस तो सब्स्टिट्यूट कर रहा हूँ n into cp minus r n into cp minus r into dt plus p into dv equal to 0. अब देखो PV is equals to nRT. PV equals to nR into T. अभी बोलो. PV equals to nRT. See 1, 2, 3, 4 the equation I am using. इसमें differentiate करो. Differentiating UV method. कहीं बोले तो इधर all are changing. So मैं differentiate करा तो P into dV plus V into dP equals to N into R into dt. सही बात है ना? अब P into dV को निकाल दो इधर से. So P into dV equals to N into R into dt minus V into dP. ये लेके इधर सब्स्टिट्यूट करना पड़ेगा. अगर इधर सब्स्टिट्यूट करें तो n into cp minus r into dt plus p into dv that is p into dv के बदले में क्या लिख सकता हूँ मैं n r dt minus v into dp is equals to 0. से क्लियर है इसका? पहले इधर तक लिखो उसके बाद में अरेंज करके प्रोसीड करेंगे. इधर expanding this equation n into cp into dt minus n into r into dt plus n into r into dt minus v dp equals to 0. ये दोनों मर गए. क्या बच गया? So n into cp dt minus v into dp equal to 0. So this is left over to us. This is equation number 1 लगा दो इसको. Equation number 1. अब इसमें से what is v into n into cp dt minus v into dp. इसमें से ई इक्वेशन से देखो केयरफुली देखो, P into dV plus V into dP is called NR dt. उसमें से dt देखो, so dt can be written as P into dV plus V into dP divided by N into R. This is equation number 2. देखिए सब्स्टिट्यूट करो, N into Cp into P into dV plus V into dP by N into R minus V into dP equal to 0. इधर तक लिखो. Now see here, after this step, Cp into P into dV plus Cp into V dP minus V into R into dP is equal to 0. R जो है ना, that cross multiply हो जाएगा. उसके बाद स्टेप देखो, मैं क्या कर रहा हूँ, V into dP को कॉमन ले ले. If I take the common, then I can write Cp minus R is equal to what? 0. Then Cp into P into dV plus, इधर Cp minus R को क्या लिख सकता हूँ, Cv लिख सकता हूँ. इधर और एक फॉर्मूला we are using it as Cp minus Cv is equals to R. Cp minus R is equal to Cv. अब Cp minus R के बदले में क्या सब्स्टिट्यूट करूँ मैं, Cv सब्स्टिट्यूट करूँ into V into dP is equal to 0. उसके बाद में क्या कर रहे हैं, डिवाइडिंग बाय Cv, ए इक्वेशन को Cp by Cv P into dP वैसे रहे. नेक्स्ट Cv by Cv V into dP is equal to 0. Then Cp by Cv is nothing but gamma है. It is a ratio of specific heats. P into dV plus ये दोनों कैंसल हो जाएगा. So V into dP is equal to 0. अब V into dP by PV, V into dP by PV plus gamma into P dV by P into V. अब क्या कर रहे हैं, we are dividing with PV, dividing with what, PV. So here dividing with the CV, dividing with the CV, here dividing with PV on both sides. So PV PV, इधर V से V मर गया, इधर P से V मर गया. देखो क्या बच गया, इधर dP by P plus gamma into dV by V is equals to 0. ये पूरा प्रोसेस क्या करें हम लोग, dt को एलिमिनेट कर दिया, dt को V एलिमिनेटेड, that's all. कहीं तो बोले तो प्रेशर, वॉल्यूम, टेम्परेचर, तीन चीज वेरी कर रही है. कहीं तो बोले तो dq is what, 0. Temperature, heat is given to the system is 0. It is called adiabatic process. In adiabatic process में अगर तुम्हारे को एक relation चाहिए, then we are trying to eliminate what, temperature. ये पूरा process जो कराना eliminate करने के लिए. Now what we will be doing is we will be integrating this one. Integrating. So integration of dP by P, which is nothing but log P, log base e P plus gamma into log of base e 0. We know that m into n into log m can be written as log m to the power of n, right? Log m to the power of n. That means log of base e P plus log of base e V to the power of gamma equals to, this is nothing but constant हो जाएगा. Integration of its 0, it is nothing but constant. So this is a constant. अब log m plus log n can be written as log m into n, log m into n. That is P V power gamma equal to constant. ये है भैया. So this is what holds good. P V power gamma is equal to constant in adiabatic process. सो सब लोग क्या करते हैं, लेक्चरर्स डायरेक्टली बता देते हैं P V power gamma is equal to constant holds good by. Okay, so आपके सर्स तो ने बताया शायद, बताया? Okay, so चलो तो बताया तो अच्छा है, नहीं बताया तो इधर सीख ले सकते, there is no problem. This is the process. So generally isothermal तो easy है, PV is equals to constant holds good, PV power gamma is equal to constant holds good in adiabatic process. Now we are ready to do work done in adiabatic process. उसके बाद में हीट इंजन, उसके बाद में कार्नोट साइकिल. चलो टेक इट ऑन. Right, work done in adiabatic process. Just now we discussed heat remains constant, dq equal to 0. Pressure, volume are changing, and in this one PV power gamma equal to constant holds to. अभी discuss करेंगे, derivation बहुत लंबा चौड़ा है. Okay, PV power gamma is equal to constant. We want work done. Work done का फॉर्मूला तो मालूम है, dW is equals to P into dV. Same we are taking a system, उसमें work done by the gas. Work done by the gas बोलते volume will be increased from V1 to V2. As same in the isothermal process what we take, there the volume is increasing. Let us take volume is changing. Here the volume is changing from V1 to V2. V1 to V2. So V1 is V1 to V2. It is increasing from V1 to V2 pressure. Now dW, this is equation number 1, equation number 2 है. This is a small work done to increase the small volume dV. Now dW from equation 1, P को क्या लिख सकता हूँ मैं, K by V power gamma. Equation number 3 एक लेके इधर सब्स्टिट्यूट करो, dW equals to K by V to the power of gamma into dV. K तो कांस्टेंट है, कांस्टेंट को बाहर निकालो, उसके बाद में उसका स्टोरी समझेंगे. Now dW equals to K into dV by V to the power of gamma. अब इंटीग्रेट करो ये. Integrate. This is a small work done. We want total work done. Always we have to integrate it. Integration from where to where? V1 to V2. Here 0 to W. By integration of dW is what? W. So this is nothing but W. W equals to K into V to the power of gamma, which is in the denominator. I will take to numerator. Numerator को लेके आओ. If I take to numerator, integration of V to the power of minus gamma into dV. We will be taking to this one, V to the power of minus gamma. Now integration of, it looks like this, x to the power of n into dx. Integration is x to the power of n plus 1 divided by n plus 1. सही बात है. This is the formula for that one. Now if I substitute that, W is equals to K into the similar manner, expanding this one, V to the power of minus gamma plus 1 minus gamma plus 1. कहाँ से कहाँ भैया? V1 to V2. Here also V1 to V2. Here limits V1 to V2. अब W is equals to K by 1 minus gamma लिखूं मैं. 1 minus बाहर निकाल. Upper limit minus lower limit. So V2 to the power of minus gamma plus 1 minus V1 to the power of minus gamma plus 1. सही बात है? So W is equal to K by 1 minus gamma V2 to the power of minus gamma plus देखो k को मल्टीप्लाई करो इनसाइड w इज इक्वल्स टू 1 बाय 1 माइनस गामा, इसको k2 लिख लो, v2 के बदले में k2, k1, k2, k3, anything we can write it as k2 v2 to the power of minus gamma plus 1 minus k1 into v1 to the power of minus gamma plus 1. तो देखो pv power gamma is equal to constant, pv power gamma is equal to constant. इसको और एक तरीके से कैसे लिख सकता हूँ, p1 v1 power gamma is equal to k1 लिख सकता हूँ, it's a constant. Next p2 v2 power gamma equals to constant, ये दोनों लेके सब्स्टिट्यूट करना पड़ेगा. ये कॉपी कर लें, as is this one, then we'll proceed. इसमें सब्स्टिट्यूट करना, W equals to 1 by 1 minus gamma into K2 के बदले में P2 V2 to the power of gamma, K2 के बदले K2 क्या है, P2 V2 power gamma है, तो लेके उधर सब्स्टिट्यूट कर रहा हूँ, right? So P2 V2 to the power of gamma into V2 माइनस गामा प्लस 1 माइनस k1 के बदले में p1 v1 to the power of gamma into, right, v1 to the power of minus gamma plus 1, ऐसा लिखते हैं. Is it clear? उसके बाद में w is equals to 1 by 1 minus gamma p2 v2 to the power of gamma. इसको मैं कैसे लिख सकता हूँ, देखिए एक बार, v2 to the power of minus gamma into v2 लिख सकता हूँ, कोई ऑब्जेक्शन है नहीं है ना, माइनस गामा प्लस 1, दिस इज 1, राइट, माइनस p1 v1 पावर गामा into, इसको क्या लिख सकता हूँ, v1 to the power of minus gamma into v1, ऐसे v1 to the power of minus gamma into. अब क्या होगा तुम्हारे को, W is equals to 1 by 1 minus gamma P2 V2 power gamma. इसको नीचे ले जा सकते, डिनोमिनेटर को ले सकते ना, we can take to denominator, then by V2 power gamma into V2 minus, सही बात है ना, so this is minus taking to denominator, then P1 V1 power gamma by V1 power gamma into V1 हो गया. अब ये दोनों कैंसिल हो जाएगा, ये दोनों कैंसिल हो जाएगा, अब क्या बच गया देखो, so W is equals to 1 by 1 minus gamma into P2 V2 minus P1 V1, ऐसा लिख सकते हैं ना. अब just reverse it, W is equals to 1 by gamma minus 1 into P1 V1 minus P2 V2, ऐसे भी लिख सकते हैं, देखो gamma minus 1 minus gamma को gamma minus 1 P1 V1 minus P2 V2. But we know that PV is equals to nRT है, PV equal to nRT, PV equals to NR into T. तो देखो P1 को क्या लिख सकते हो इधर, P1 V1 equals to N into R into T लिख सकते हो ना? Similarly, P2V2 equals to N into R into T2. तो क्या होगा तुम्हारे को? Next इसमें substitute करो. Then W is equals to 1 by 1 minus gamma into nRT1 minus nRT2. और W is equals to nR को बाहर निकालो 1 minus gamma into T1 minus T2. T1 minus T2. W is equal to nR by 1 minus gamma into T1 minus T2. Is it clear? So this is the work done in adiabatic process. अब क्या क्या सीखा? एक बार just will write it as which will be. So in this class, what we learn, एक बार revise करेंगे. To learn now Carnot cycle के लिए Carnot cycle or Carnot engine. First one we discussed work done in isothermal process. What is work done? W is equals to 2.303 nRT log of base 10 V2 by V1 or in terms of pressure P1 by V8. Second one, first law of thermodynamics, dq is equals to du plus dw. Third one, dw is equals to P into dv. Fourth one, what is the Cp? Equals to dq at a constant pressure by n into dt. Fifth one, Cv is equals to dq at a constant volume by n into dt. Sixth one, Cp minus Cv is equals to R. Seventh one, gamma is equals to Cp by Cv. उसके बाद में eighth one, gamma is equal to Cp minus Cv. Cp minus Cv is equals to R. Gamma equals to Cp by Cv. Next, eighth one, we discussed PV power gamma equal to constants in adiabatic process. Then work done, ninth one, work done equals to nR by 1 minus gamma into T1 minus T2. So these are the things we learned in this one. And isothermal process work done in adiabatic process. These are the derivations we discussed. Fine. So next we'll be discussing heat engine. Then we'll start up with Carnot cycle. Is it clear? Just note it down.
Hey guys, I hope you have enjoyed this video and please make sure to like and subscribe and share with all your friends.
If you have not done this before, please subscribe to Physicsframesgrb. As exams are nearby, this will be very helpful to us.
So guys, hope you have understood all the questions. These questions are going to be really helpful for the exams. Please like and subscribe to the video. Thank you.
Hello, my name is Anahu Shodhan and I'm from Indus Universal School and I'm a student of Einstein Academy of Excellence. This academy has helped me a lot, whether it is being able to retain the answers or really practicing on my homework and other problems, which I didn't really used to know how to do before. But since because of the teaching and supervision of the teachers in academy, I've gotten a lot better in maths and science.